I think with the size of audience that we have, we can talk a lot, hopefully. So feel free to interrupt, ask questions, share experiences, pull out things that matter more to you than I'm talking about, and we can try to talk about them maybe. And I'll just add that I also went to a Waldorf school. I went to the Kimberton Waldorf School from 1st through 12th grade, and I grew up in a Camp Hill. And Liz and I kind of overlapped there too, because she came to Camp Hill after I left. So
Camp Hill is a Waldorf school, a boarding Waldorf school for children with developmental
yeah.
issues.
So I think that I'm going to try this and see what you think. If I give you a whirlwind tour of the highlights, or some of the highlights, of a math curriculum through the grades, and then we can spend the second part, or the part after that, talking about principles and ideas and thoughts about, come on in, that might guide a teacher or a parent or a child, and see what we think about that. In the past, when I was at the very early days of the Waldorf School in Cape Ann, before it became called the Waldorf School of Moraine Farm, I would often go out, I mean very often, often in the first year, twice a month, to talk to people and share what Waldorf was about, try to attract children and parents and so on. We would do all sorts of events. But sometimes I would get to a library and there might only be one or two people there. And maybe the mathematical part of that is that it really doesn't matter if you just have one or two people with you, because if one of them enrolls, you've done good, right? So that's what I mean about conversation, to talk about really what is it here. And I like to always start by asking or thinking together as parents and teachers, what do we really want for our children, right? And kind of in the fairy tale spirit, you know, with the walnuts that you can crack or the blessings that you can give, what are the things that you can give to children? Now my phone is on airplane mode. I try to get agreement on this with everybody, but for example, can we agree that we want good health for our children and enduring good health? And so when you come to the Waldorf school and you ask, what helps with good health? One of the clearest things is you have to establish it first, right? The first thing you want with a baby is good health. In fact, in a strange kind of way, almost nothing else matters. And as the children get slightly older, it continues to remain one of the most important things. So if for example, if a child suffers starvation, say, young, that may never be recovered for the rest of their life. If we suffer starvation, say, for a year or two, we might recover in a few years as well. So this notion of trying to foster and guard the child's health is paramount to the early years of Waldorf education, and it still continues as a conversation well into the grades. What can we do to help with sleep? What can we do to help with nutrition? What can we do to help with joy that produces great health? What can we do to foster the sort of rhythms of the day that result in health and so on? But if we just turn it into a kind of category, we can say that it remains primary throughout. We always want our children to have good health. But we need to start focusing on the second gift pretty early on too. But particularly the grade school teachers need to have a clear eye on emotional well-being, right? That we have children who are motivated, that we have children who have a positive self-image, that we have children who can find meaning for themselves, right? That their emotional lives can be fostered and grown and turned into a kind of robust confidence as they start to go more and more out into the world. Can we all agree that we want good health and a robust emotional well-being. Is that fair? And then the last thing that we want that really rests on those two things, but that we all think we want and we're thinking about, especially when we come in the grades, we're always thinking about that first, is how much does the child know? How well can they cope with the world? What are their thinking skills like? What are their other sort of worldly skills like? How well can they do sports? How well can they maybe play a musical instrument? The learning that we normally associate with school is sort of the last gift that we want, so that children enter the world absolutely at home with being there. So, and that may be where we have the conversation. Children should enter the world sort of as they become more independent, certainly by the end of 8th grade, pretty much feeling that they have at least a rudimentary understanding of what is going on in the world, on a physical level, on a political level, on a practical level, that they know about money, they know about investing, they know about computer hard drives, they have a sense of how the internet is working, they have a sense of some of the assets in the world and some of the dangers in the world, so that we really can feel confident that when they become more independent, they're not going to be lost or feel like strangers in the world. Is that a fair gift to give? A penetrating understanding, right, of the things of the earth, right, how stuff works. So after we all agree, like you guys are agreeing, I would sometimes then say, so do you want to enroll? Right? Because we're going to be doing that stuff. And in the earliest days, these conversations were often one-on-one when the school was very, very, very young, just having started, and we were looking for parents. I got a long list of parents who had attended events before there were any teachers even at the school. This was a parent initiative. Our school was founded by a parent initiative. And I would go into these homes and have this conversation, sometimes for an hour or an hour and a half, and ask them if they wanted to enroll. And then I'd say, that's great. And I have an application with me. And I'm going to wait until you filled it out so I can take it back to school. And by the way, you are admitted. And I'll see you in September. In that way, I was able to enroll the 14 first graders in our school, and by the second grade that we had 22 of them. And I began as the kindergarten assistant at the very, very beginning, and had to have a second job as well while we were doing that. And then we just grew from there. And it was a lovely process. So let me kind of narrow down the curriculum and do a whirlwind experience, perhaps, or you have to sort of envision what the children might be grasping or gleaning in math. And chip in if you want from experiences that you have or questions that you have. But obviously in the first grade, we introduced counting, and I think Waldorf schools are famous for trying to add a qualitative aspect to number. So certainly in the early days, we talk about what is it like, and we don't even necessarily say one, right? We introduce the concept of unity. And in fancy math, one is called unity, right? And it's just, that always thrills me. Like, you take 5 and unity, and you get 6. Right? And if you take this unity and let it sort of overflow or unravel, you can start to perceive number in it, right? So you can take the unity and take it in half. And now we already have 2. You can take it in quarters. You can divide it in thirds. You can let this unity, kind of like cellular life, right, in the first days of conception, right? This, what was unity, now produces a whole world of reality. You can bring in creation stories, and there's often beautiful egg stories of how unity gets fractured into the world, the heavens and the earth and the water. And I mean, the Kalevala is a great example of that, for example. And pretty rapidly, they have not only a sense of the numbers, but they have a feeling that they can manage them, right? That they can work with them, and counting becomes a great joy and pleasure for them. And if they're a little OCD, sometimes, this happened to me in my class, for example, one of the children, I think I was trying to master all the operations up to about 12 squared, 144, but I still remember he was mumbling in the back half an hour later, and it's like, yeah, 2,327. Right? It's like, okay, Kaylin, you could stop. We're good. And this sensation that they had with not only the numbers but with the operations was almost like a totally new lens by which they could peer into the world. For example, they knew for a long time before then, because I was a kindergarten assistant, that my wife was older than me. But with their new math ability, I would sometimes overhear, yeah, because they called me George in those days, when George was born, his wife was 8. Imagine that. Right? And they were maybe a little before that age, trying to imagine that somebody that might just be born could later become their spouse. That was a stunning thought. Right? Somewhat unreal. I remember hearing two of the young boys in a tree. Their parents were Baba lovers who followed Mayor Baba. And I remember them talking very philosophically. But it had to do with this age question. And the question that they were trying to resolve was, who came first? Mayor Baba or God? Right? And could their mathematical skills possibly give them a chance to at least get closer to an answer for that? I think you can imagine that first year is a beautiful foundation of confidence as well, that the children start to feel that their ability to manipulate the operations and to satisfy their questions and interest gives them a really strong reward. And then in second grade, I remember just reviewing a little bit this whole division thing from Unity, and I just picked very, nothing sacred about it. You don't want to, cut up or break, precious things. So we just took a piece of paper and divided it in half. The pieces in half again, the pieces in half again, right? Powers of 2. It rapidly climbs very high. I think by the end of the morning, we probably had 2,000 little pieces of paper, maybe 1,000. I still remember this little girl comes to my desk at the end of the morning. And can I take that box home? Right? You want to take the box home? Sure, why do you want to take the box home? I want to cut them in half again. Right? And you can start to, again, see this growing feeling of strength and investment that they have. I got a lot of funny questions in that in that year. I remember I had what I thought was a really intense math block. And I was trying to sort of channel the Waldorf spirit and wrap it in story. So we had a fantastic adventure with our class where we were in some kind of wild island or something. And every challenge that came up could only be resolved by figuring it out mathematically. Like we had a couple of ropes, and how long were they and how deep was the cliff, and which ropes did we have to tie together to get to the bottom of the cliff, or we had to span a gorge and the lengths of wood were so and so long, or we had a certain amount of food, and how were we going to share this out. And so because they wanted the story to continue, they were very rapid in answering these mathematical questions, which they seemed to not even notice at all. And I remember when I had my early parent meeting after the block had started, one of the parents said to me, I just want to check this. I asked my son what you're learning at school, and he said nothing. George is just telling us a story, right? And after I could explain it, it all became clear. But it was just one of those wonderful things where you can see how being totally immersed in an activity, you almost forget that you're exercising those skills, right? And second grade was like that, where we teach the algorithms certainly for addition and subtraction, bigger numbers and so on. Maybe some simple algorithms for multiplication and division. But by the time they come to third grade, their ability to work with numbers, manipulate numbers, to explore things with numbers becomes much stronger. And in third grade, we also have an opportunity to make it very practical. So I had that adventure on the island that was somewhat imaginative, whereas in third grade, where we have, you do farming things in third grade here too, you do trades and things like that. So we happen to grow up in an area of granite quarrying and fishing, and you know, the lovely trades that come with shipbuilding and all those things that come back from the water in Gloucester where I live. And so we were able to explore measurement of all kinds of dimensions. And they particularly loved the exploration of liquid measurement, where they could try to, I balanced sort of personal measure with sort of universal measure that we've agreed upon. And this whole notion of where does measurement come from? Where do we get the inch? And is that a thumb? What's a hand span? And they were particularly tickled that they could use as a unit of measure a mouthful of liquid, right? Like, how many mouthfuls is a cup, do you suppose? Well, they were eager to discover that, right? And then they were eager to share their results. And whether we drank it or whether we spat it out, those were questions they weren't so concerned about. We made our universal yardstick, we made our personal yardstick. And each child then had a personal yardstick. We had a wooden sort of long yardstick that was easy to carry around and use. And we also had things, another tape yard that we could wrap around and so on. We measured distance up to miles, and how to do that efficiently, and how to, we had to take our yardsticks. It took quite a while to get a quarter mile and then a half mile. And eventually we tried to cook up together some more efficient ways of measuring greater distances like miles. Like maybe we could get a quarter mile rope, perhaps, and instead of just using the yardsticks all the time. Or could we rapidly lay them down, have somebody counting, and then the end runs to the front, right? And we went on. So dry measure, wet measure, liquid, and so on. And then it came to the question of measuring time. How do you experience time, right? So we knew, for example, that we were waiting for the guests that we wanted to come, but we really had no idea, without checking our phones all the time, what kind of time it was. And the children were interested in this. Do we have a sense of time? Can we even feel time? How accurate is our sense of time? And so we practiced together. Can we say, all feel what a minute feels like? It was very hard with various results. I often did it this way. I played an open note on the piano with the pedal down, right? So it like a deep note that could last really long. And then the students would all say how many seconds that took. Our results were hugely different. And then eventually we had a blackboard like this, but it had a frame all the way around. I took the blackboard out and I hung a mallet on a cotton thread, on a piece of yarn. And instead of sort of just counting inwardly, we watched the pendulum of this mallet. And then I played the long note, and I asked them, so how many pendulum swings did that take? And we all agreed. Pretty close. Maybe a half pendulum swing different. Some people heard it last a little longer, they weren't sure. And now we started to measure all sorts of times with our pendulum. I didn't particularly study how long the thread should be, so it wasn't tied into clock time, but they felt like they had a very reliable measure of time. A string with a mallet. Probably a third of the class came up to me after that lesson and said, "Can you help us set this up at home?" Right? So that they could have a way of measuring time too. Right? A heavy mallet on a string about this long can swing for quite a long time. And later on in 7th grade, we might explore that how the period of a pendulum is the same regardless of how wide it swings, right? So none of that we discussed particularly. But it was just, again, one of those wonderful things. How do you measure area when you're working with third graders? What's a fair way? Right? Is it fair to say, we're just going to measure this edge and then multiply the two? That's how we measure area, right? I didn't think that was a fair thing to do as a way to measure area, because it's not an area measurer, right? So we'd have to find something else. You could have a certain quantity of dust that you sprinkle if you can sprinkle it totally evenly. That didn't work. We tried how many pieces of paper, square feet, because we cut them square feet. How many square feet could one stock mark crayon cover, right? That was quite a bit. We tested that out. But eventually, I gave them all what were reasonable area measurers, which were square inches. And we had 144 of them so that we could measure a square foot. Each of them had enough material to measure a square foot. And then together as a class, we could measure all sorts of square feet. And backwards from that, they took their square, I think they actually had an independent square foot too, so they could even get bigger measures. So square inches, like just pieces that were flying around the classroom, but they try to keep them together because they're precious. And pieces of paper, square footage. And we could get the square footage of our classroom and the hallway and the dining area and all the things that interested them. Their bedrooms, how many square feet they were. And it wasn't an abstract square footage. It was, how many times does my piece of paper go round, right? And so this feeling, again, of entering the world with interest and competency, I guess, would be what they were starting to feel. It was another window, another approach, another tool, a new vision of things. In 4th grade, moving on to fractions, we did something that takes too long for me to explain here. But I basically introduced number theory in 4th grade so that we could talk about the different kinds of numbers. You all know what a square number is. You know what a square root is. We discovered those. Do you know what a perfect number is? Has that been discussed enough to be familiar? Certainly some of the teachers who I've worked with know about that. There are such things as perfect numbers. There's abundant numbers. There's deficient numbers. We invented symbols for all of these. And once we had our various understandings of numbers, we did research. I required them to discover all the factors of all the numbers, for example, up to 100, to catalog each number as abundant, deficient, prime, right? What the perfect, if we came across one, which we did under 100, and start to have an activity and a goal that was not assigned, but almost drew them towards it. Most of them could not stop at 100, especially when we were looking for abundant numbers. An abundant number is a number that has very many factors. So many factors that when you sum them up, not including the number itself, it adds up to more than the number, right? And so if you think of the factors of 12, for example, 1 goes in, 2 goes in, 3 goes in, 4 goes in, 6 goes in. You come up to half, right? And if you add them up, they're more than 12. They rapidly discovered that multiples of 12 are superabundant. 24 was abundant, 36 even more. By the time that they started catching on to this, they rapidly inspected 360, right? Which is super abundant, right? The factors of 360, as I remember, add up to more than twice 360. So you can divide it all sorts of ways. Thanks.
Thank you. I have another meeting.
No problem. All sorts of ways without having to have a fractional remainder, right? And later we reflected, where do these numbers appear? How are they familiar to us? Because they're very familiar, right? And it didn't take them long to figure out that, yeah, 12 hours on the face of a clock, 24 hours in a day, 36 inches in a yard, 12 inches in a foot, 360 degrees in a circle, right? And the sense that they got, now this is fourth grade, remember. How many of you have fourth graders, by the way? And the rest of you with older children, do you remember fourth grade a little bit? Would it be fair to say that that year was an adventure, right? We have Norse myths. We have a certain, I don't want to say sauciness, but they are able to express themselves in a way that you might sometimes be taken aback, right? For one thing, they know, maybe they're starting to know more than you. They certainly have answers before you can give them. They're devising things, they're arranging things. It's a lovely year. We often think of big changes in the third and fourth grade. And but suddenly they thought, and they looked at me, it's like, you mean the people from a long time ago were smart enough to set this up like that? It's like, yes. When we set up feet, when we set up inches, when we set up yards, when we set up, surveying and mapping with 360 degrees, when we did that, the people who did that, long, ancestors long gone, they were brilliant, right? And suddenly a sense of connectedness to the past, of respect for their elders, of interest in the concerns of their elders, could be a little bit sparked. It was at that age, for example, that they could also reflect on their lives in a numerical way, and some of the students in my class could calculate in their heads how many days they had lived. Occasionally we would just ask, so today, how many days have you lived? And a few minutes later we would get some responses, just mental math. They really enjoyed that. They enjoyed recipe, like increasing recipes, for example. It's a fractional activity, and it pays off because it's likely that, George is going to bring in something that we've studied in a recipe, now that we've multiplied it enough to double it or triple it. So all sorts of abilities come in. And one really critical understanding I thought had to be established, which I wonder if we even think ourselves, but in fractions it was critical. I'm going to turn the stand around because we're being recorded. But when you do division, you can take a number of items. Let's pretend we're looking at the apples under a tree, right? So I've got 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got the apples under a tree. They've fallen down. We've gathered them up. And maybe we want to share them among 3 friends. Perhaps everybody wants to make a pie. So we're going to take those 4 and maybe those 4 and these 4. It's pretty simple. And how do we represent that mathematically? Right? Is it not true that we would say 12 divided by 3 equals 4? Is that a fair mathematical representation of that? So let's think of another practical situation. Maybe we're building a wall. And of course, our bricks have to be exactly a foot long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I won't bore you with building a whole wall, but we will get a few bricks underneath anyway. There's a half brick here, right? And then a whole brick here, and so on. So let's just say our foreman is coming to measure the wall that our client or our customer requested, and our foreman is going to measure it. So we have a yardstick, right? That's the first 3 feet. Then another 3 feet, another 3 feet, and another 3 feet. Fair enough? It's 12 feet, and we had to use the yardstick 4 times. So we could say, is it fair to say, in this case, 12 divided by 3 equals 4 also represents that operation? Fair enough? What would you call this? Just randomly. Is it fair to say sharing? Since you're not jumping out. And this has an even more obvious name. What would we call this?
Building.
What? We certainly would call it building, but what I did with the yardstick, what would you call that? Measuring, right? So we can share or measuring. Okay, we can share or measure. And mathematically, our symbolism does not tell us if we're sharing or measuring. Do you agree? Because here's the circumstances are quite different here. Here we divided by 3, and we got 3 groups of 4. And here we divided by 3, or measured by 3, and got 4 groups of 3. Could you say that's a very different situation? 3 groups of 4 is very different from 4 groups of 3. And in real life, we want to know, do we have 3 groups of 4 or 4 groups of 3? And we want to also know, are we measuring or sharing? Students appreciated that because in fractions, you are only ever measuring when you divide by a fraction. You are never sharing, right? And if you can't make that clear to students early on in their work with fractions, their intelligence gets confounded. Because an intelligent student, let's say, when asked, what is 3 divided by a half, will intelligently say 1.5. That's half of 3. Do you see what I'm saying? But if I said to a student, or she understood, you know what, I'm just measuring by that half. How many times does half fit into 3? That's easy too. And now their intelligence can be rewarded, right? A half fits into 3 6 times. And I met teachers who used to present it to the children as a wonder of nature, that when you divide with whole numbers, the answer is always smaller than what you started with. But if you divide with fractions, the answer is always bigger than what you started with. But I don't think that's fair to make into magic. I think what's really fair is to say to the kids, the reason that makes sense is because you're measuring. And often what you're measuring with is smaller than the thing you're measuring. So it's going to fit in more than once, right? And that kind of clarity helped in 4th grade. I'll try to go a little quicker now. In 5th grade, we dive into decimals. Well, let me ask you this. Do you like decimals? Am I not mistaken? Or when you have to calculate with decimals, isn't it that the best tool is your calculator on your phone, right? If you're dividing in decimals, if you're multiplying decimals, if you're adding up decimals, if you're doing money calculations, if there's any challenge to it, you want to use a calculator. Why? The kids are no different from you, right? They're wondering, why are we doing this? And for a while it lasts that there's a practical use to decimals. It's a different form of fractions. You can master it. It's not a problem. Of course, they've lived with them simply all their lives. There's nothing new, really, a fraction. Everybody in kindergarten knows what half of a cookie is, right? But there's got to be something more. And so in my search for something more in decimals, I thought, how can we explore decimals? How can we research decimals? How can we get some interest in decimals? And so I first asked them, when you divide, say, 1 by a number, when will it just end? Right? You get a decimal answer, but it doesn't keep going. Like 1 divided by 2. It just ends, right? 0.5. 1 divided by 4 also ends. 0.25, right? What else will allow a decimal to end? For example, if you do 1 divided by 8, will that decimal end? Do you know what it ends at? Isn't it 0.125? Right? Right? Yeah, so some of them end. They like those the best for a while because they're the easiest. And so we might as well take a look at them in 5th grade and say, okay, why are they so easy? What makes them easy? And we noticed that after some exploration, any power of 2 or 5 or their multiples and terminate, the fraction terminates. All the rest keep going. 1/3 keeps going. 1/6 keeps going. They're all. But among those that keep going, there's some interesting ones. They repeat, right? They have a pattern for a while, and then they repeat. Now, you might think that they're not interested in that. They're way more interested in that than they are in constantly calculating, what the butcher had to get for change, et cetera, et cetera, et cetera. Like you make up those problems that they know are totally fake. They're much more interested in their parents' bank accounts, for example, and I don't ask them to look, right? But sometimes I get reports, right? We closed on a house. Yeah, your parents closed on a house? Yeah. It was like $625,000, right? Now, they have to pay that off over 30 years. It's okay. We're going to talk about that more in 6th grade, right? But take 1/7, for example. Now, I could write this out, or I can just tell you. 1/7 doesn't end. It's beautiful. I'll write it quickly. If you have, good thing we fixed the board, right, Liz?
I know.
I don't need a board assistant.
Well, I would always help you, George. I always
Thank you. All right, so 1/7 goes like this. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. Now, it repeats again and again and again. And you can start to notice some cool things about it. For example, this is a period of 1 divided by 7. How many digits in the period? 6. Can we split that group in half? Right? Yes, we can. And do we discover, for example, that if we take the division point here and we add the first, the second, and the third, we get 1 and 8, 4 and 5, 2 and 7, and what do we get?
9.
Each time it's 9. That's kind of cool, right? We've been drilling it into them since they were in 2nd grade that 9 is a cool number, and the multiples of 9 are also cool, right? And now we're interested, are there any other fractions that have repeating periods where we might discover this pattern? And if so, we only have to get the first 3, and we can figure out the last 3, or the last 4, or the last 5, if the period, is 6 or 10 places, right? We start looking for a place of research again. And the students are actually interested in it. They're interested in putting together their practical research too. For example, we took all the metrics of the students in our class. Height, weight, girth, right? Head circumference, hand span, right? We collected all this information, and we tried to be sensitive. They taught me how to be sensitive because some of them didn't want their weight disclosed. So of all the data that was associated with each child, the weights of the children were secretly submitted to me and randomly distributed in the class. So we could still get the average weight of our class, but nobody had to reveal it. But it did allow us to start looking at what we might call simple statistics, averages, and things of interest to them. We discovered, for example, that the growth pattern of the boys and the girls diverged slightly, both the weight and the height. New insights that they had about each other, but they were interested, right? And in 5th grade, through Egypt, we also had to figure out, say, how the Egyptians lay out their land. How do they build their pyramids? And I chose to take a theme all the way through, from 1st grade all the way through 8th grade, the theme of a circle. What can you learn about a circle in 1st grade? What can you learn about a circle in 2nd grade? What can you learn about a circle in 3rd and 4th grade, right? Dividing the circle, so on and so forth. In 5th grade, it seemed to be time to discover the relationship of the circumference to the diameter of the circle and to get pi. The Egyptians used pi to build their pyramids, that relationship of the height and the circumference of their pyramids. They actually had to make the edges not quite straight so they could get it to be close. And we built a pyramid in our class, and they loved sitting inside of it. They discovered the mythical, perhaps, or maybe the real qualities of pyramids, for example. It used to be that you could buy a little cardboard box in the shape of a pyramid. It was said to realign the molecules on the edge of your razor and keep it sharp. People meditate in pyramids and so on. Of course, their parents know more about that than I do, and so they'd be feeding me that information. Pyramid tense and so on, pyramid vitality, you hold water under a pyramid, all sorts of pyramid things. But for me, I was interested in pi. And I didn't do much more than 22/7, but later on, that grew and grew and grew into 6th, 7th, and 8th grade, so that by 8th grade, we really could do a urgent analysis of pi. They would constantly bring me newspaper clippings of the next time that pi got taken to the next 10 million places, right? Or the first billionth time that, a supercomputer in California had calculated pi, etc. We had little incentives, for example. If they could find a number that was more abundant than 360, I would give them a book. Right? A reasonable book of their choice, perhaps, or something like that. And their parents got into that, so I would be fed all this information. It came to my attention that Daniel Tammet had taken the challenge of memorizing and breaking the world record for the digits of pi, right? It doesn't have a pattern. The digits don't end. It's not like 1/7. They keep going in random order. It seems forever. That's a mystery in itself, and of course, we had to attend to that before they left 8th grade. How can this be, right? But if you had to remember the digits of pi, who knows them relatively well? 3.14159. What's after that?
7.
Yeah, who knows, right? But if I actually sincerely asked you to put your back into it, how many do you think you could remember with work? Let's say you took a month or 2 or 3 to study the digits and remember them. Do you think you could break 100? Do you think you could break 200? Perhaps not. The kids wondered too. One or two of them tested their skills. Daniel Tammet was able, in a challenge which also raised a lot of money for a charity of his choice, to recite 22,514 digits of pi correctly, without error, in 5 hours and 9 minutes. Continuous recitation. Wow. Okay, so they're a little interested in the people who do math too, and sometimes we tell them stories of that and so on. So Gauss was a fascinating mathematician, and the things that he discovered and invented helped the fifth graders tremendously. Again, how not to be bored with simple division or decimals, a new way of showing remainders that he called congruences, which my students then were able to practice, where you can get more than one right answer to a question, the coolest thing on earth. By the time we moved into sixth grade, we were totally ready for what we had to do, which is mostly business math, working with percentages and interest and so on. And there's so much emotion with business, so much investment in things that the numbers sort of signify. Right? It matters not just for math how you keep your bank balance and how big it is, but it also speaks to a lot of other things in your life, right? And they're interested in those things. They're interested in making their own little businesses. I remember we talked about the difference between, selling things and bartering things. And again, like that thing hanging on the board, one day we had a barter day in sixth grade. And they brought in stuff they could barter with each other. I can't tell you what a blast they had trading the junk that they had in their rooms with each other, and how gleefully the people who had got them walked home or went home that day with them, and the ones who had gotten rid of them, for a while their parents were happy just for that one day until they brought all the junk home that they had gotten. Right? But again, can we do that again? You mean trading stuff with each other? You want to do that again? Right? Stuff you can do any day. But again, with this new lens, with this new awareness, and with this new lens, they could understand more about Rome. They could understand more about the Middle Ages, about the trades, and about the merchants, and about the wealth, and about how you needed capital for businesses and so on. I was shameless, and I told them the biography of Emil Molt, who was the founder of the first Waldorf school. He started a cigarette factory in Europe. He supplied a lot of the cigarettes that went to the front during the First World War. And he had a guy in his factory who could roll 3,000 cigarettes a day. That was just of interest. But he amassed a pretty good fortune and spent most of it on founding the Waldorf School, eventually having to give up his entire factory because he had gone into a consortium which went bankrupt. Not his factory, but his factory had to be dissolved. And by that time, there was a lobby in Germany that prevented him from founding another one. The other manufacturers prevented the founding of a new factory. So he basically gave his livelihood and his fortune to the founding of the first Waldorf school. And I didn't think the kids in sixth grade were too young to know what the sacrifices were that they were getting. We talked about tuition at that point. How much were their parents spending on their school? How much had they spent since they'd come to school, right? Their extra lessons and so on. This is business thinking, right? I showed them the numbers for the school, the annual report for the school, what we took in for revenue, what we spent. It was aggregate. They didn't know what my salary was necessarily. I wasn't necessarily sharing that. Not that there's much to hide, but but lots of interest, right? And suddenly they could take an interest in other businesses in town. And we could look at balance sheets from local businesses and go to the Chamber of Commerce and write letters to different chambers of commerce and so on. The whole thing kind of blew up. It was beautiful. Seventh grade, huge challenges emerge in math. It's so exciting, the power that you can get, not just with the interest, formula, which is really more of a formula than an equation, but once you start having the ability to manage equations, what you can do and solve, right? For example, a cool problem that they really crack their teeth on. How many minutes past 3 exactly do the hour hand and the minute hand lay directly on top of each other, right? I would challenge anybody in here to solve that problem. They looked at the clock. They broke the clock, right? Moved the hands. You can guess pretty close, but you can't guess exactly. And so you have to use an equation. You have to figure it out. Practical things, we studied the golden ratio in geometry. We got golden ratio calipers and discovered, like the research we'd done in 5th grade, how well proportioned every single person in the class was, whether tall or thin, right? How their bodies were formed on the golden ratio. And how they could start to penetrate with understanding almost anything that would come across their plate. Both beautiful things, practical things, how buildings were constructed and so on. And it was the beginning of a doorway that allowed me to go into 8th grade and think that it was possible to make a challenge so great for them that the math in the class was impossible for most of them to do alone. And so I spent a long time in preparation with them, talking to them. I actually brought my little sheets that we worked with here, about how we would undertake a challenge that we already were convinced that we couldn't solve alone. When you eagerly take a challenge that you know you can solve, you think carefully about a strategy to do it, right? And so we looked at each other in the class. Some of the kids in the class were pretty math genius. They were so math genius that parents were starting to ask, maybe they should go out for extra tutoring or different tutoring, because you can't challenge them enough, or they're not grasping enough. And we worked and talked and thought, how do you challenge a person to do something so difficult that maybe at first blush they can't do it? And the thing is that they discovered, and didn't take them long, that to get a group to work well together, math skills is just one. And it allowed us to talk about a lot of social qualities, a lot of social assets that, again, they weren't so conscious of in the class before this challenge. So we came up with 5 things that we need in a group. We need somebody who's good at motivating the group. They may not be great at math, but they may be great at getting the people who are good at math to get their rear in gear, right? And get the materials and the things that they needed from the whole group. We agreed that we need curiosity. Who may not be so super at math, but just can't stop asking the group questions like, what if we tried it this way? How can we do this, right? And the curiosity to explore other solutions, to go down other roads. Of course we needed somebody who has an interest in computing and possibly in technology and programming. In my class, I sold it to them, and this is something that your school will have to debate on your own. We chose calculators. And I felt that because we don't have a high school and my students are going to go into an environment where calculators are required, I wanted them to be relative masters of the calculator, right? Graphing calculators. So we had graphing calculators, and we needed students who were at home with that kind of technology. So that had to be in the group. Because the problems were hard, not just mathematically, but conceptually, we needed people with strong reading skills. We all agreed on that. And so that everybody in the group could come along, we needed somebody in the group who had the patience and the imagination to be a good teacher, right? Who could help everybody stay together. And then we made a deal. If the problem I gave them was so hard that a group couldn't get it, they could call another group. The groups were not competing with each other. They could call another group for help. If that group didn't get it, they could call a third group. At that point, they knew that 3 groups couldn't get it. At any time of the night, they could call my home and say, there's 3 groups that can't get this problem. And I would immediately send out the message to all of them, you don't have to do that problem for tomorrow, right? We'll do that in class. And so they knew that the work was super hard, but they also knew that it wasn't going to kill them. Because really, if 3 groups couldn't get it, it was clear that we had to do it together, right? And so we went through the year, and I just wanted to give you some of the topics that we covered, which totally captivated them. We started with voting, and it's a perfect time of year now to look at our voting system and how, why do other countries have different systems? How do those systems work? What's a runoff system? How can it be, for example, that under certain systems, if somebody early on in the runoff process, for example, gets more votes, later in the runoff, they might be knocked out. Whereas if they got lesser votes, all these amazing, confounding things about democracy that only math could reveal how incredibly challenged our simple system is, right? We had to invent for decisions in the class a better voting method. We love that. How are we going to serve the lunches? What are we going to serve? Where are we going to go on field trips? All that stuff. We're going to vote, and we're not going to vote in the simple majority way. We're going to vote more intelligently. That was a great math lesson. We got into cryptography. We got into codes and cracking them and making them. We got into satellite imagery. How do we map the world? How does a GPS sort of use the information that's coming from satellite imagery to go on? And what's a pixel from the satellite? How does that look like? We looked at all that. It was just before it took off, on your phone or in your cars. It was a good time to look at that. We worked with linear equations. We talked about wildlife, populations, the effects of human beings. Really going out into all the concerns that the adult world has in a deep mathematical way. And one of them that was of particular interest to them was drug testing. We looked at probability. When you take a drug test, for example, what's the chance that you're going to get a false positive or a false negative? Research knows what the chances are. And yet they knew from the news and from their friends that just because there was a small chance that you get a false positive, did that mean you weren't arrested? Does that mean you weren't even charged before you were given a second or third drug test, right? And so we explored, in sports, they're very interested in sports, drug testing in sports, drug testing for recreational drugs and so on, and also allowed us to have a lot of conversation about drug abuse and all the sort of ethics that come along with staying clean, which in 8th grade I think is a reasonable conversation to have. And if you can back it up with math, you can have the conversation naturally. It doesn't have to be a lecture. So our sort of crown of our achievement in 8th grade was getting a good handle on the quadratic equation so that by the time they went into high school, they were very confident, solid, and had a lot of experience to go on. I found that my students mostly were a year or more ahead in the schools that they went to. And not because we were trying hard, but because they'd had practical experiences. We did conic sections, for example, in a really graphic way, drawing them, cutting cones, and so on, which they never would get in high school. So when they got conic sections in high school, which is really hard math, they knew exactly what they were talking about, what a parabola was, right? What an ellipse was, and hyperbola and so on. So making them at home in the world, and we just talked about math so far tonight, right? But there's every other subject that we could talk about on other nights. So let's just talk a little bit about the world of math, right? You might think that math is useful. What is math useful for, right? Well, what I've been trying to sell you tonight is that math is actually useful as a field of growth for children. I'm not talking about them becoming bankers. I'm not talking about them becoming businessmen. I'm not talking about them becoming this or that. I'm talking about having an environment where growth and exploration and playfulness allows them to really manifest their whole human being, right? So taking it from this guy who has a phenomenal book, if anybody just wants to play with math and do stuff, phenomenal book, A Beginner's Guide to Constructing the Universe, not a Waldorf book, but hidden in many Waldorf classrooms. The coolest book, and he gives a quick synopsis. There's 3 kinds of math. There's secular math, what he calls secular math, which is mostly quantitative and commercial. We often think that's what math is about. You need to learn how to do things in math so you can build bridges and fill bank accounts. Mostly when you practice that with students, they get quickly bored, right? It has a clear goal at the end and an end. The second form of math, he calls symbolic math. You'll see it widely celebrated in Waldorf schools. The exploration of patterns in nature, the discovery of sequences like Fibonacci and so on, which we do in 7th grade. Geometric patterns, the spirals that make storms and seashells are formed by the same laws, discovering those laws. Symbolic math, we call that. It's beautiful, it's full of meaning, and there's a huge field of exploration there for children. They love it, okay? And then he says there's the third kind of math, which is called sacred math. And that sounds kind of maybe Waldorf-y, but we don't teach it a lot. But let me give you a characterization of it. It's an approach to math where math takes you in so deep that it's transformative, right? Mathematicians go there, right? It's where your very deepest identity seems to be reflected in the math that you're doing, okay? People like Gauss or others. Erdős is a great book. You should read The Man Who Loved Only Numbers. It's a phenomenal book. So it's where and he has this great line from the book. I love to quote it, so I'm going to do that. The power which we seek is the power with which we seek. Do you get that? The power which we seek is the power with which we seek. We suddenly see ourselves reflected in the world. To me, that's the final reward of being at home in the world, being well educated. So pursuing those things, having books like that. But the children have to do it. You can't compel them. You can't force them. You can't. It has to be exploration. It has to be interest. It has to be playful. How can you cultivate a home or an environment where interest, exploration, and play, research the problems they get so that they can try things different ways, change the problems. They were forever coming in my classroom, changing the problems on me, right? Well, that was more interesting, right? I also had an understanding with them that if they ever detected something I had asked them was stupid, they didn't have to do it, but they did have to justify why they thought it was stupid, right? So, for example, if I take the average of the incomes in this room and one of you is a multimillionaire, the answer to that problem of the average income is nobody's income, not even close, right? Because there's such a huge outlier. Well, they often detected outliers in my problems, like, that's stupid, right? Make the averages make sense, et cetera, et cetera. So lastly, maybe just in one last minute, what are the children seeking in all this? We want physical health, we want mental health, we want them to be at home and competent in the world. We want them to be masters of the knowledge of the times. What do they want, right? And maybe to end with this. And this is in a lovely book by this guy. He's a psychologist called Deci, Edward Deci, Why We Do What We Do. He gives a very compelling case that what the kids want, they want to be competent. Every human being wants to be competent, right? It's hard to stand in life and feel that in every arena you're incompetent. So be competent. They're seeking competence. Give them competence. They're also seeking autonomy. How and when can we give them a safe autonomy? All right, I'm not suggesting you let your kids roam around New York City at 3 o'clock in the morning, but at least at a certain age, they have to be free to do that, right? When and how do we introduce autonomy so that they have a feeling of autonomy? Don't ask them to decide if they want to go to the Waldorf school in 3rd grade. They're too young for that responsibility. But maybe they have other areas of autonomy. Competence they want autonomy. And finally, every human being, every child wants connection. They want to feel connected to their family. They want to feel connected to their teacher. They want to feel connected to their class. They want to feel connected to their community. They don't want to be strangers in this world. They want to feel connected. So if we can read their urge, their need, their asking, as it were, their requiring competence, autonomy, and connection, then I think you'll send really strong, sort of well-balanced children into the world who will be healthy, who will be emotionally stable, who will know what they're up to in life. So let's end there. Thank you so much.